Okay, imagine trying to secure a massive modern city that's constantly under construction. I mean, new buildings are popping up, roads are changing every single minute. That's pretty much what managing security across AWS, Azure, and GCP feels like. So, how do you actually protect it all without bringing everything to a screeching halt? Today, we're digging into one of the biggest, yet quietest threats out there and how to build an automated defense against it. All right, so let's put you right in the driver's seat. You're that senior multi-cloud architect. You have designed this beautiful, secure system that spans across all the major clouds. It's elegant, it's resilient, and everything is humming along just perfectly. But there's a hidden danger lurking in the shadows, something that could silently undermine your entire creation. Now, this isn't your typical hacker in a hoodie you see in the movies. No, it's something way more insidious. Picture this. A developer is on a super tight deadline. They need to quickly test a connection, so they temporarily open a firewall port. They absolutely intend to close it right after, but then, an urgent meeting pops up, they get pulled into another fire drill, and they forget. That one tiny, seemingly harmless change, well, it can add up, creating a massive security hole you might not even know exists. And that right there, that's the ghost in the machine. It's called security configuration drift. And honestly, it's one of the biggest, most underestimated threats in cloud security today. It's the quiet, unassuming reason behind so many major data breaches, and it's something every single architect needs to be obsessing over. Think of your security baseline as the steel and concrete foundation of a skyscraper. It's strong, it's stable, it's engineered perfectly. Now, drift is like these tiny hairline cracks starting to appear in that foundation. That forgotten firewall rule, that's one crack. An automated script with a tiny bug, that makes another. A misconfigured setting on a new storage bucket as a third. Now, one crack probably won't bring the building down, but hundreds of them over time, they weaken the entire structure and create these hidden pathways for an attacker to just walk right in. And this slide shows a perfect and, frankly, a terrifyingly common example of drift in action. On the left, that's your golden rule. Port 22 is locked down. Why? Because port 22 is the primary door for administrative access. It's where you get the keys to the kingdom. But on the right, in the drifted state, that door is now wide open to the entire internet. That's like leaving the door to the bank vault open with a neon sign flashing, "Help yourself." And trust me, automated bots are scanning the web for this exact mistake 24/7. Okay, so how do we stop this from happening, right? How do we prevent these tiny cracks from turning into a catastrophic failure? We can't just check things manually once a quarter. The cloud moves way too fast for that. The answer is to build a system of continuous security and governance. Think of it like an automated immune system for your architecture that is always on and always watching. And this system is built on three really key pillars. First, detect. This is your motion sensor. It has to alert you the instant a change happens that deviates from your plan. Second, validate. This is like your regular inspection, where you take your master blueprint and you walk the perimeter, making sure every single wall, door, and window is exactly where it's supposed to be. And third, govern identity. This is your master key system, making sure that only the right people or automated systems have the keys to make specific changes in the first place. So when you're validating, what does good actually look like? Well, you need two sources of truth. The first is your own company baseline. This is your unique custom blueprint. Maybe your company has a strict rule that all data must be stored in a specific region. That's your baseline. But you also need to check against industry best practices, like the CIS benchmarks. Think of these as the universal building codes for cloud security, developed by global experts. You absolutely need both, the building codes to be safe and your own blueprint to be functional. Now, for the best part. Seriously, this isn't some complex, expensive new platform you have to go out and buy. The really great thing about this approach is that you can build this entire framework using the powerful native tools that are already built right into your cloud platforms. The whole toolkit is already at your fingertips. So let's meet your crew. In AWS, your key player is AWS Config. Think of it as a meticulous historian that records the exact configuration of your resources and, crucially, tracks every single change over time. When that firewall rule for port 22 gets changed, Config sees it and logs it instantly. Over in Azure, you've got Azure Policy, which acts more like a proactive gatekeeper. You can configure it to not only detect violations, but to actively prevent them from even happening. And in GCP, Cloud Audit Logs are your definitive record, giving you a super detailed trail of who did what and when for every single action taken in your environment. So, what's the bottom line here? What's the real payoff for setting all this up? By implementing a continuous security and governance framework, you fundamentally shift from a reactive to a proactive security posture. You stop waiting for a scary audit report to tell you what went wrong last month, and you start preventing problems from ever happening in the first place. It's about having true awareness and control in real time. Ultimately, your architecture is no longer just a static blueprint. It becomes a living, breathing system that's constantly adapting. For instance, when AWS Config detects a dangerous drift, it can trigger an automated response, like a serverless function, to immediately revert the change. That's self-healing in action. This is the real power of continuous security, turning your architecture from a passive fortress into one with an active, intelligent immune system. But hold on, there's one more critical piece to this puzzle. We've built the perfect, self-securing fortress. The architecture is solid, but what about the people and the processes that are deploying code into that fortress every single day? This is where DevSecOps comes in. DevSecOps is a culture and set of practices all about baking security into the entire software development lifecycle, from the very first line of code. It's a huge topic, and it's how you connect the secure platform to the people building on it, and we'll definitely be diving deep into that in a future explainer.